Welcome to today's webinar, announcing AWS Lambda Edge. Our presenter today is Nihar Bihani. He's a Senior Product Manager for AWS. Today with us, we also have Meena, Senior Product Manager at AWS, who will be going through a demo later in the presentation. We also have Subham as our webinar moderator. He will be engaging with you and answering your questions throughout the presentation, while Nihar and Meena present. Nihar, welcome. The floor is now yours.
Great, thank you, Ryan. All right, welcome everyone, and thanks for making the time to attend today's live webinar, bringing AWS Lambda to the edge. It's a preview feature that of AWS Lambda that we announced at the recent AWS reInvent conference a couple of weeks ago. And my goal, along with Meena and Shubham, is to walk you through the new functionality that we announced, and how you can sign up for this, and walk you through how you can sign up for the preview. So let's get started. Over the next hour, we'll spend time starting off with a background on AWS Lambda and Amazon CloudFront, because each of those are their own services by themselves. And then we'll talk about Lambda at the edge and how we have integrated those two services to give you a unique functionality. We'll do a demo, or Meena will do a demo of Lambda at the edge. I'll walk you through a customer case study, one of our customers, Cloudinary, and how they are already utilizing this feature and what advantages they see. Then we'll talk briefly about getting started in preview, and we'll have time for Q&A at the end as well. So starting with AWS Lambda. AWS Lambda, think of that as the evolution of cloud compute as we've come to know it towards serverless. Now, serverless is an interesting term. It's defining something as a negative about what it's not. So let's talk a little bit about the root of that term and what that really means. So, it's been about, AWS is about 10 years young, and, one of the first services that we launched was Amazon EC2, or Elastic Compute Cloud, and that gave you the ability to rent virtual compute instances in the cloud to run your applications on. You could rent a single instance, or a dozen instances, or thousands of instances as you needed them and as demand increased for your application. Pay only for what you use, and turn them down or turn them off when you didn't need them, so you didn't incur any costs. However, there's a lot of overhead that came along with that in terms of having to manage these instances where all you wanted to really do is run your application code. With these underlying instances, you had to configure them, to set them up, the scalability, the deployment, all of this management is something that developers had to do themselves. What we heard from developers is that this isn't really what they wanted to focus on, what they wanted to spend their time on, and they wanted to instead really focus on the efforts around application development. And so, with that came the evolution of containers. Containers give you the ability to, within these instances, define multiple levels of isolation within which you can run your applications. So you can define multiple containers within an instance, group them however you'd like, and be able to simplify that deployment and management that you had to do by yourself when you were running raw instances. But under the covers, even with containers, you're still managing fleets of instances, and you still potentially have some idle resources that are it's certainly less than when you were running your own infrastructure, but it's still more than zero. So imagine an environment where you have the infrastructure and the application code is just running there, and you don't have to worry about what's underneath. You don't care about what else is running on that infrastructure, or who else is running the applications, just the same way you don't care about who else has a bucket, for instance, on Amazon S3. All you care about is that when your application needs to scale, when demand increases for your specific application, there is room for your application, and things like security, scalability, deployment, management, all of these are just taken care of. and all you're really focusing on as a developer is your own application code. So that's effectively what AWS Lambda is. So AWS Lambda, it's serverless computing, but you can think of it as event-driven computing because the model of serverless is very different. When you set up your servers to run your applications, you're thinking about, in most cases, handling HTTP requests for your applications. And your application is then serving in response to those inbound events. But in the cloud, there's so many more things that can generate requests that just inbound web requests is just one of them. You can perform, for instance, log analysis when your file is put into an S3 bucket, or you can, whenever a row is inserted or updated into a DynamoDB database, you can do something similar to, for instance, a SQL trigger. You can perform different actions in the database or do some sort of external operation. Another common use case that we see with AWS Lambda is Lambda as the producer for API gateway. So instead of having your fleet of EC2 instances behind an ELB handling web requests, and then having it be idle when it's not handling those web requests, instead you have Amazon API gateway call AWS Lambda to perform a function. You can also trigger Lambda functions off of mobile backend calls. You can call AWS Lambda directly. And now with Lambda at the edge, you can actually call Lambda functions in response to CloudFront events. And we'll talk more about that later in the presentation. So the benefits of AWS Lambda or serverless computing is you have no servers to manage. It scales with demand for your applications, and you never pay for any idle capacity that you had to when you were running instances, or even worse, when you have to manage your own infrastructure. But all of these Lambda capabilities, these Lambda functions today, are triggered from within a single AWS region. And this is where the edge comes in. So with the edge, what do we mean in this context with the AWS edge? It's the global network of points of presence, or POPs, that are connected to the backbone of the internet. So the service that you may be familiar with that AWS offers today is Amazon CloudFront. It's a content delivery service. So let's talk briefly about what CloudFront is and what it can do for you. So CloudFront is a global content delivery network. It can help accelerate your static content, your images, videos, as well as your dynamic applications and APIs, all of your interactive content. It's massively scalable, very secure. It's self-service, like everything else at AWS. You have full API access to configure anything with Amazon CloudFront. And from a pricing perspective, it's pay-as-you-go, pay for what you use. So it's on-demand pricing, and it's priced to minimize costs. You don't pay for the peak of your traffic. You pay for the amount of data you deliver. And CloudFront can help deliver all types of content. So a lot of customers I talk to understand the benefits very clearly of a content delivery network such as CloudFront for their static images and also for their videos. But fewer customers understand dynamic content and how a CDN can benefit for their the interactive pieces of their application, whether that's user input, whether that's personalization. And there, with CloudFront, connecting to AWS's backbone network helps with network optimizations, can really help, even if you're not caching content at the edge, can help accelerate the delivery of your the dynamic pieces of your application. And of course, security with SSL. And the thing that customers really appreciate about Amazon is you can do all of that and accelerate all different types of content without changing your backend at all. And this will become very relevant when we start to talk about Lambda at the edge and how you can utilize the Lambda at the edge functionality, put it on CloudFront, and put CloudFront in front of your application without needing to change your backend. So with CloudFront, you can define what we call cache behaviors. Cache behaviors are based on URL paths. So when a user, as you see on the left here, requests content from CloudFront, CloudFront will go to a different origin, and you can configure CloudFront to do that based on whether it's dynamic content or static content. So now imagine if you could run your Lambda code that we talked about and all the benefits we talked about of Lambda for your applications across a global network of these edge locations. So across 68 points of presence and 9 regional caches, across 21 countries and 5 continents. So this gives you the ability to run your Lambda functions really, really close to where your actual end users are. So joining the two, putting it together, Lambda at the Edge. And so this is the feature that we announced at reInvent recently. Lambda at the Edge, it's an extension of AWS Lambda, allowing you to run Node.js code at AWS global edge locations. So it's a Turing-complete environment, allowing you to write arbitrary code and import third-party libraries. You can write code in your home region, Northern Virginia, and deploy it seamlessly to all of CloudFront's global edge locations with the click of a button. Lambda at the Edge offers the following benefits. So in addition to what we saw for Lambda, no servers to manage, continuous scaling, and never paying for idle capacity, you now also get the globally distributed set of locations where you can run your Lambda functions at. So again, just to visualize that, write once and run everywhere. The way CloudFront works is wherever your viewers are, they get routed when requesting your content to the closest CloudFront POP, and then that's where your Lambda function would be executed. So for instance, your users in Australia would go to our POP in Sydney, for instance, and even if your origin were to be in Northern Virginia, your Lambda functions and the customizations that you put in there would happen very locally to those users with really fast response times. So we'll zoom in, bringing up the same diagram that we saw earlier, and we'll zoom in on the actual CloudFront POP and talk about the different ways in which you can write Lambda functions and associate them with different CloudFront events. So there are 4 different events that are supported today with CloudFront, where you can associate Lambda functions. And keep in mind that the Lambda functions can be associated on a per cache behavior basis. So as I described earlier, cache behaviors are essentially different URL path patterns. So the first couple of events I'll talk about are viewer request and viewer response. So again, to the far left, you see the end user making a request to CloudFront and then getting a response back. So on the request piece, the data that you would want to change in response to an end user request. For example, some sort of authentication, cache key modification, or perhaps something that you want to pass as a parameter to querying the cache itself. So those are some of the scenarios where you may want to write a custom Lambda function and apply some logic. On the response side, it would be more about end user personalization. So after a response comes out of the cache and is ready to be delivered back to the viewer, you can personalize that content based on the logic that you put in your Lambda function. Then on the origin side, so you see the origin on the far right here. Again, there's 2 different events. There's the origin request and the origin response. So the origin request and response events get triggered when the request gets through the viewer stage due to a cache miss. So the object is not already in cache, and CloudFront needs to go back to your origin server to fetch that object. So in the case of a cache hit, when your object is available in the cache, the only 2 events that would get generated are the viewer request and the viewer response. But in the case of a cache miss, you would also get the origin request and the origin response events generated. So in thinking about the origin request and the origin response use cases, for origin request, you could think of use cases such as routing to different origins based on, say, some sort of logic that you need to apply, or some sort of custom origin authentication, or manipulating URLs that you may need to. So, the end user has a simple user-friendly URL that comes in, and you need to change that to get data back from the origin. for reasons such as integration with legacy systems. For origin response, once the response arrives at the CloudFront Edge location, you're then able to manipulate that response to potentially change headers, modify the response before caching it, and before it's handed back to the end user. The thing that I wanted to highlight is that for each cache behavior that you have in CloudFront, so for each path pattern, you may define 0, some, or all of these events. So all 4, viewer request, viewer response, origin request, and origin response, and associate up to 4 different Lambda functions for each of these 4 events. So it depends on your use case and which path pattern you want to invoke some customization at, and at which part of the request for the response. So I briefly mentioned a few things that you can do with Lambda at the edge. Let's dive deeper into some of those. So content customization. Here, for instance, you want to look at the property of your users in terms of where they're located or what device they're using, and then select the content accordingly. In terms of image resizing for mobile versus desktop, selecting a different page based on the location, the geographic location of your viewers. So localized content. Client devices and the properties of those devices. You can delete or modify headers to match different protocols required by legacy and user devices, whether it's TVs or network printers, and do other customizations based on the actual device. Visitor validation. So there are different types of bots. There are good bots that you may want to serve your content unmodified, but then there are also bots that you do not want to serve your content and maybe want to display a CAPTCHA. So you can look at that information in the request headers and decide what content to serve. You can look at the validity of sessions based on cookies or token-based authentication. You can add access control headers accordingly. So again, gives you a lot of flexibility in whatever logic that you want to apply, and then rewrite URLs or add or delete headers. We talked briefly about this, managing multiple URLs. So from an advertising perspective, you may want your URLs to be simple and from what user puts into their browser, but then they get translated into a different URL before the request goes back to the origin. Or from images that you may want to drive revenue for. If an image URL comes in without the HTML context around it, you may want to actually add the HTML context with some contextual advertising information so that you can earn advertising revenue for delivering that image. A/B testing, this is another one that we hear very frequently from our customers. With Lambda at the edge, you have the ability now to flip a coin right at the CloudFront Edge location, very close to your viewers, and display a different version of the content to each viewer that's requesting that. So you can have, for instance, 2 or 3 or multiple variations of the content. And if a cookie is already present, then you serve, say version A or version B. But if there isn't a cookie present, you can write a cookie right there by doing a random flip of a coin, and then deliver the right content. So again, this is an example that we'll go through when we do the demo. You can see some code here. It's JavaScript code, relatively easy to write, and gives you a lot of functionality to do this sort of logic right at the edge locations. So at this point, I'm going to hand it over to Meena, and she will walk you through setting up a CloudFront a Lambda at the edge function and associating that with the CloudFront distribution, and showing how this can work.
I'm actually going to go through a demo of the A/B testing example that Nihar just talked through. And the way I have it set up right now is that I have a very simple S3 origin behind my CloudFront distribution and a couple Lambda functions that will help split traffic and make sure that people continue to see sticky sessions moving forward. So what we're looking at right now is my very simple S3 bucket for this demo. I have basically image A and image B stored in here, and I have cookies configured under the metadata to ensure that one object is tagged as image as A and the other one is tagged as B. Next, I have a CloudFront distribution that has this S3 bucket configured as the origin for it, and I have all of my cache behaviors. I have very simple cache behaviors associated with this particular origin. Now, the more interesting part is creating a Lambda function that we hook up to this CloudFront distribution. So what you do here is basically start with the Lambda console and start with the Edge Node.js runtime. With this, today we have a couple blueprints which give you canned scripts that are ready to go that can be hooked up to your CloudFront distributions. You're also welcome to use a blank function if you have very specific logic that you're trying to implement to start from scratch to set this up. So in this case here, I'm going with this A/B test function that we have available to us. And I'm working, essentially what you do today is very similar to how you would configure a Lambda function to be triggered by other supported services, such as S3 or DynamoDB. Here I have a CloudFront distribution selected, and I specify exactly which cache behaviors and which trigger event for a CloudFront request I want my function to be triggered by. In this case, for the A/B test, I want to basically execute some logic every time a request lands in terms of looking at the request to see, hey, is this a viewer we've seen before? Have they already seen an A version or a B version of the page that we're trying to display, and can set a cookie accordingly? So the viewer request is this step in the process here I want to execute logic at. So when you go through, the next step basically lets you look at the code and customize it to exactly what you're interested in here. Right now we have a URL which points you to an experiment pixel that we execute this logic on, and the next thing we do is basically set up two particular objects for group A and group B that we want to point traffic towards. What the function here does is essentially go through and see if a cookie is set for a given customer, and if not, flip a coin and say 75% of the time have my users directed to group A, and the rest of the time have them directed to group B. The one other thing I want to point out in this console is some of the particular runtime restrictions that are pointed out on this page. It's items such as timeout and the memory available to the function. And the thing to keep in mind here is that Lambda at the Edge functions are really optimized for the kind of use cases that will benefit from executing at the edge and executing in line with a CloudFront request. So I had previously set up the same function and had it point to the image A and image B that are in my S3 origin here today, and set it up and confirmed the triggers with the same CloudFront distribution that we looked at the viewer request level. The next thing that you need to do here is, in addition to looking at each viewer request, right before responding to the viewer, ensure that your custom header, which in this case is setting a cookie for your A/B test, is configured right before you respond to a viewer. So this is when you fetch the object from S3 for the first time, you read what the default cookie is for that particular object, and set that cookie right before you respond to the viewer, so that you're able to identify the viewer before you respond to them the next time. So I set up a URL and had this deployed, and you'll see here we're requesting experiment pixel, but what we're actually receiving is, in this case, I believe it's image A from my S3 origin. And if you, inspecting this, what you'll see is that you do have the cookie to show up, and it's set to A in this case. And just to demonstrate the fact that we are randomly selecting what is displayed. I also request the same URL with a different browser as a different user, if you will, and you see that a different image shows up. But in a nutshell, that's basically what the flow, the number of clicks, and the number of pieces of logic that need to be put together to set up something like a simple A/B test. Moving forward, right in the Lambda console, we're working on building out more of a library of blueprints in this manner. I know there were some questions around visitor validation that came in through the group. So those are the kind of things we're looking to build out, and we look forward to hearing from you, from the audience here, on what other use cases would be helpful to build out a few starting points and building blocks for. I'm going to hand it back to Nihar to talk a little bit more about one of our AWS partners who builds, who have been building a few functions on using Lambda at the Edge today, and to see what they've been doing with it.
Great. Thank you, Meena. All right, so as Meena said, let's walk through Cloudinary and who Cloudinary is and what they are doing with Lambda at the Edge. So Cloudinary is about a 5-year-old company, and their aim is to provide an end-to-end video and image management solution to their customers. It's a cloud-based software as a service. Their customers are primarily web and mobile developers, and their solution covers many components of the image and video management pipeline. So as you can see here, starting with uploads, storage, asset management, and then their use case for Lambda at the Edge actually centers around manipulations done on images and video. So transformations such as resizing, cropping, adding watermarks, or images within a video, and so on. They also use CDN to deliver these assets, these images and videos with high performance to viewers around the world. Cloudinary is a fully API-based system, and they're completely modular, so developers can pick and choose which component they want to integrate into their application. And they have, as you can see at the bottom, they have 160,000 developers who use their service, ranging from startups to large enterprises. They manage about 11 billion media assets for them, and they're doing these transformations at the rate of 2,000 transformations per second. So, Cloudinary, I'm sure you can relate to this. A lot of Cloudinary's customers, they all have something in common. They all have images that they serve to their end users. So I'm sure you have your own images and videos in your applications. And one thing that's worth thinking about is if those images are loading as fast as they possibly could. Are they optimized for each user? So especially as you have to deal with all different kinds of devices that come into the market and new devices being introduced, different resolutions, different browsers, different network locations, or network characteristics, usability, responsive layout. There's a number of different things to think about as you're delivering your content, your images and videos. And you want to make sure that you're providing the best experience for your users. And this often requires making dynamic decisions based on a lot of these variables that I just mentioned. So this is where Cloudinary utilizes Lambda at the Edge as a solution for what they need in terms of making these dynamic decisions. Their architecture, you'll notice here, looks very similar to a diagram I showed earlier in terms of the request and the response paths. But this is in context of the media assets that Cloudinary manages and processes through CloudFront. So in this case, specifically images. So on the left, you'll see there are users downloading images from different browsers, and the URL for those images, along with some specific information about its users, like user agent, the image type, different hints from the client. these URLs are being sent to Cloudinary's code, which is deployed within Lambda at the edge at a CloudFront location. And then this Lambda at the edge code helps transform the URLs such that Cloudinary's backend origin servers to the right of this diagram, those origin servers can then optimize these images on the fly and then respond back to the user with the best possible image. So I'll walk through a couple of different examples of what Cloudinary is doing. So here's an example of what they're doing with Lambda at the edge. What you see here is a few different browsers. And as you know, there are many types of users that have a lot of choices in terms of the browsers that they're using. And to serve them with the optimal image for their specific browser can be quite a challenging task. First you have to figure out what is that optimal image for each browser. JPEGs are great, but now there's also WebP, which is Google's compressed image file. There's JPEG XR, and really deciding which image type to serve to which browser. It's a problem that Cloudinary is solving for their customers. So if you look at the URL here in the address bar, the blue portion of the URL helps with resizing the image, but the F_auto marker in the URL in red, that sends a message to Cloudinary's Lambda at the edge function to select the best format of that image. And that's the format that then gets sent back to the browser from CloudFront's cache, so that the best fit image based on, again, Cloudinary's mappings of browsers to images and image formats is delivered. The net result is that the images look great in that browser, but given the compression that WebP and JPEG XR, for instance, provide, you can get a smaller file size delivered from CloudFront that helps you save data transfer costs and deliver those images faster over the network. And when talking to Cloudinary and looking at their use case, what they said that what they really like about the solution is that they didn't have to change, again, any of their backend origin configuration or any of their code. It's the logic that they put into the Lambda at the edge function that allows them to bring these customization decisions at the CDN layer close to where the browsers or where the viewers are that are requesting these images. Here's another example, similar to the previous one, again for images, and shows how Cloudinary uses Lambda at the edge to deal with responsive images. This is in response to the different types of devices or browsers that are out there. You want to serve the optimal image again to fit the design of your web page. So ideally, you want to generate a different resolution image for each screen that's out there. And if you do that in advance, this could be a large number of combinations of images that you would have to produce ahead of time. And so there's way too much data to store and manage. So again, Cloudinary helps solve this using client hints. And as you can see in the URL, there's the W_auto and DPR_auto markers. And these are, again, the hints that their Lambda at the edge function uses to generate the best image to fit that screen. And what's great, talking to Cloudinary's CTO, they told us that Lambda at the edge presented a really elegant solution for them for what they needed, but just by writing a few simple lines of JavaScript code to achieve this with Lambda at the edge versus writing hundreds of lines of sort of conditions and instructions with some of the other solutions they were using. Here's a last example of what Cloudinary is doing. This is changing the image quality specifically for mobile and saving mobile data. When there's mobile devices running in poor network connectivity areas. So again, there's a marker, as you can see in the red, Q_auto, and these are all customized to Cloudinary's logic in Lambda at the edge. But again, similar idea, this URL, the Lambda at the edge function uses it to resize or change the quality of the image in a way that's unnoticeable to the human eye, but helps save bandwidth and helps deliver these images faster to those mobile devices. So lastly, again, talking to Cloudinary, they are very excited with the possibility and all the things that they can do with Lambda at the edge. Looking forward, they are seeing the things that they could do, such as adding a security layer or viewer location based on IP or referrer or other data to determine how to control the quality of their images or manipulate or transform their images before they get delivered back to those users. For instance, Cloudinary allows you to change color of images, as you can see here, or change or overlay text on images, and just generally provide a better and more customized experience to their viewers and make those decisions much closer to those viewers right at the CloudFront Edge location. So the last thing I wanted to talk about before we jump into Q&A is how you get started with Lambda at the Edge in preview. So just to recap, with Lambda at the Edge, you bring your own code. It's self-service through the AWS Lambda console, as Meena showed. It's a familiar Node.js programming model, and you write your function once in your home region, and you can run it anywhere. It gets automatically deployed across the AWS network of 68 edge locations, and then when your viewers make a request, they get routed to the edge location that's closest to them. So we have a bit.ly URL here. So if you just type that into your browser, that should take you to a preview page where you can fill out a form. There's some information there. You can learn more about the product. You can also fill out a form, tell us about your use case, and then once we get that data from you in a few days, we will review that and get back to you, and you should receive an email whitelisting your account ID, and then you should be good to go to write your Lambda functions on the Lambda console and deploy them globally to CloudFront Edge locations. So again, it's bit.ly/Lambda at the Edge. Okay, and you should be able to click on it as well. Before we end, I wanted to, Meena alluded to this a little bit. I wanted to talk, briefly about the service limits. So the runtime is Node.js 4.3. Triggers are CloudFront events. And in terms of access for the preview and today, given that these functions run at CloudFront Edge locations, you don't have network connections or access to AWS regions, access to disk or Amazon VPC. So those are some of the limitations. Couple of other things. So timeouts, again, Meena talked about this briefly, but I want to spend some time on this. There are many things that you can do with AWS Lambda at the region, like I described, like log processing and such, and that can take several seconds or even minutes. But with Lambda at the Edge, you should really think about that as code that you are running to personalize the experience of your viewers very close to them. And you want that code to run very quickly so that you can respond back to these end users as quickly as possible. So we actually have a timeout of 50 milliseconds for Lambda at the Edge. So this is really intended for very quick computations that happen just in a few milliseconds or tens of milliseconds. And you can customize the requests or the responses. The function power level or the memory footprint here that we're supporting right now is 128 megabytes. Node.js runtime tends to be pretty small, so that should give you a good amount of space to work with for your application code. And then finally, the function deployment packet size is 1 megabyte. So just want to make sure you're aware of these service limits as you're thinking about your use cases. From a pricing perspective, Lambda at the Edge is priced along the same dimensions as AWS Lambda is priced at today. So that's the function executions and the number of executions, as well as the duration or the compute time. Pricing for Lambda at the Edge is listed here and also on our website. It's 60 cents per million function executions, and then a number of zeros and 125 per second of execution duration. It's a small fraction of a penny for each execution, for each second of execution duration. So just to give you an example of what that means, if you look at 10 million executions that are roughly 50 milliseconds each, the total compute charges, compute time charges, and the request charges add up to $9.13. So this is the last slide I have. What I wanted to leave you with is, there's a, we've launched this in preview, Lambda Edge, and there's a ton more functionality that we are considering adding to the product in the coming months. And what we really need is your feedback in prioritizing what we should be building. More than 90% of our roadmap at AWS across all of our services is influenced directly based on feedback that we hear from our customers. And so, please give us feedback via this webinar, later on via the AWS Lambda forum, or use the product in preview and let us know what you think and what additional functionality you would like to see. That'll really help us prioritize the order in which we build these features. That's all I had. At this point, we will move on to the live Q&A portion.